Okay, so today we're in section 13.5, graphing a linear equation in standard form. All right, this doesn't mean that we're actually graphing it in standard form. Basically what it means is it's going to be written in standard form and then we need to graph it. And there's two ways that I can graph a linear equation when it is written in standard form. So I know you're just dying to know, what is standard form, right? I mean, isn't that what you were asking? Like, just tell me, I can't wait to know, right? Sure. Well, here you go. Standard form. AX plus BY equals C. AX plus BY equals C. Okay, so what we're doing here is we're saying that you can rewrite any linear equation that's written in this standard form. Okay, and I'll show you what I'm talking about in just a second with this format. And I can rewrite it in slope-intercept form. All right, so here's the equation. 3x plus 4y equals 24. So standard form says the x and the y term are on the left side of the equation, and then the number by itself. That's what standard form means, okay? So instead of it being in standard form, we can rewrite it in slope-intercept form, and that's one of the ways that we can graph it. We cannot graph the equation as it is right now in standard form. We can't graph it, okay? You can't just say, oh, the slope is 3 and the y-intercept is 24. It's not ready to graph yet. So what would be my first step to get it from standard form down into slope-intercept form? What would be step 1, Jason? Yes, minus 3x. And why do I minus the whole thing? Because it needs to be 0. It's got to move to the other side. So to get it to completely cancel, I have to subtract the entire term to the other side. And now I have 4y equals, and these cannot be combined. They're not like terms, but which one comes first? Yes, negative 3x plus 24. Now what do I do? Anybody remember? Just tell me. Yes, divide the entire equation by whatever is connected to y. And now I have y equals negative 3/4 x plus 6. And now I'm ready to graph it, all right? So what are we doing here? We're taking an equation that was in standard form and we're writing it in slope-intercept form. Basically, we just did example 1, all right? Any questions on that? Any questions? So this is a lot of actually what we've already been practicing with rewriting, and then we're just going to transfer it over to a graph. So everybody should agree these equations are not ready to graph. In 13.4, it was like, all right, graph this equation, and it was already in slope-intercept. Well, here, they're in standard form, and I need to get them in slope-intercept form, just like I just did in the last slide. All right, so I want you to see if you can get started on it. If you're stuck, that's fine. All right, but let's see who can get started on this first one into getting this equation from standard form to slope-intercept form. What would I do first, guys?
Add 2x.
Yes, I would want to add 2x. Get that x term to the other side first. I need to add 2x. And then what? Yes, divide everything by 3. So add 2x. And then remember the x term comes first. Hold on one sec. That should be... Then divide everything by 3. Y equals 2/3 x minus 2. Minus 2. Okay, 2/3 x minus 2. So now it's in slope-intercept form. Now I want you to go ahead and set up this graph if you haven't already. Just go ahead and set up this graph. We're going to graph 2 lines on this graph. We're going to graph 2 equations on this graph. What is, someone raise your hand, what is the first point on the graph for this equation? All I have to do is look at the equation, y equals 2/3 x minus 2, and I know where my first point goes. Kennedy? On negative 2. The number at the end of the equation, guys, remember, is your y-intercept. So if it's negative 2, my point goes on negative 2. But how do I know where to go from here? How do I know if I'm going up or down? How many to the right? What tells me where I go from this point? Zach? The rise over the run, my slope. The number that's connected to x. 2 is my rise because it's positive. I go up 2 and right 3. Up 2, right 3, plot my point, draw my line, and I'm done. Okay? Do you see where I got that from? So I started here at my y-intercept, and my slope told me rise 2, run 3. So I went up 2 over 3 and plotted my point. Okay? And then drew my line. All right, I want you to go ahead and start working on the second equation now. Get it in slope-intercept form, and then see if you can get the graph on your graph. Same graph. Use the same graph. Okay? Go ahead and use the same graph. Don't do a new one. Yep. All right, so what do I do first? What do I do first? Add 2/3. Guys, the very first thing. All right, y'all are already solving it. Add 2/3 to both sides. Y equals 2/3 x. Okay? Plus 0, but we know that plus 0 means that the intercept is just 0, right? We don't even have to write it. So my first point goes on the 0, and then where do I go? Up 2 over 3. Sounds kind of familiar. Are these lines parallel?
Yes.
How do you know that?
Because they're on the same intercept.
Yeah.
I mean,
the same slope. My rule says if my slopes are the same, the lines are parallel. Now, the y-intercept has to be different, right? It has to cross the y-axis at a different point. Otherwise, it will be the exact same line. All right? So they are parallel because they have the same slope. That's awesome that you guys were kind of picking up on that. That's really, really good. All right, any questions? Any question? So really, this should have looked pretty familiar, rewriting the equation. It just took a few more steps because it was in standard form to get it to slope-intercept. In example 2, I'm just showing you a different way now to graph a linear equation when it is written in standard form. So go ahead and write these 2. I need you to skip probably 3 or 4 lines in between each equation. And we are going to do 2 graphs, or 2 lines on one more graph. We're going to do one more graph today. You need to set up one more graph. Go ahead and set up these 2 equations. And again, skip like 4, maybe 5 lines in between. All right. So, okay, looks like you guys are still setting up. Give you another minute. Okay, so to graph using now x and y intercepts, all right, well, what's the point of doing this? Well, it takes a few steps to get it into slope-intercept form. Would you agree? So instead of manipulating the equation, we can actually, when we're finding x and y intercepts, we can leave the equation just the way it is. All right, so that kind of eliminates that part of the work. But in order to find an x-intercept and a y-intercept, so 2, I actually need to rewrite the equation. I need 2 equations. The same exact equation, you're just duplicating it. So on the first equation, I can find the x-intercept, and on the second one, I can find the y-intercept. All right? So go ahead and write it twice, just right next to it. Go ahead and write the equation again. Okay? And again, that's because on one I'm finding x, and on the other one I'm finding y. All right, go ahead and write it again. Okay? Now, here's my rule. If I want to find the x-intercept, I need to substitute 0 for y. I can't have two variables that I'm solving in an equation. I need to get rid of one of them. So in order to do that, I'm going to give y a value of 0. So now it's x plus 3 times 0 equals negative 3. All right? So to solve for the x-intercept, I substitute 0 for y. All right? So what's 3 times 0? 0. Just cancels out, right? And what am I left with? X equals negative 3. Okay? And now I can make this into an ordered pair. I can see by the way I solve the equation that my x value is negative 3. And what value did I plug in for y to get that x value? 0. So that's my ordered pair. Okay? Now I'm going to do the same thing for the y-intercept, except this time, if I'm finding the y-intercept, what do you think I'm going to plug in for x? 0. Finding the y-intercept, I plug in 0 for x, and I get 0 plus 3y equals negative 3. Well, again, does 0 have any value? No, so don't worry about that. How would I solve for y? Divide both sides by 3. These are going to be really simple equations to solve. All right? Y equals negative 1. Anybody have a guess as to what my ordered pair would be? 0, negative 1. Okay, 0, negative 1. Now I have my two ordered pairs that I can graph. I need to caution you guys, make sure you go the right direction. Negative 3, 0 does not mean down 3. Negative 3 is your x value. That means you go left 3. See that? And then, where do I go for 0, negative 1? No, well, I go 0 on x, but then where do I go for negative 1? Down 1. And then draw your line. Okay, you see what I did there? Now, when I tell you to graph using the intercepts, both of your points should be on the x and the y axis. If you were to graph this equation, guys, it's really important that you understand this. You could have graphed this equation using slope and y-intercept. But would you have had a point on the x-axis? No. Okay, you wouldn't have. So that's why it's important you have to follow the directions. There's more than one way to graph a linear equation. So if it says use x and y intercept, this is how you do it. All right, you with me? Okay. All right, let's do the second one. 2x minus y equals 8. So remember, write it twice. Okay, and I want you to start finding your x and y intercepts. Use the one right above us that we just did. Okay, so when I plug in 0 for y, what would I divide both sides by? Divide both sides by 2. X equals 4. 0. Who got 4, 0? Raise your hand if you got 4, 0. Okay. All right. What about the second one now? 2x, so 2 times 0 minus... Wait, why would I put the 1 in front of the y?
Because it could be...
Yeah, because can the y be negative? No, and 2 times 0 cancels. But now I'm left with negative 1y. I can't have a negative y, so what would I do to get y by itself? Divide by negative 1. So it would be negative 8. Okay, so go ahead and fix your graphs if you had positive 8. All right, now I'm going to go a little bit off my graph, but that's okay. All right, not a big deal. Go ahead and graph now this linear equation. Okay, so negative 8 and 4. And there's my graph. Does yours look like that? Yes. All right, great job, guys. Okay, so that's example 2. How are we doing, guys? Doing okay? Aramis? Xavier? Doing okay? Iona? Yeah. All right. It's okay. It's all right. Well, sleepy. Anybody else sleepy? We're almost done, guys. Example 3 is coming up. Okay? We'll come back to the application question. In example 3, you have $6 to spend. Has anybody ever gone to the farmer's market? Downtown? Or I guess downtown, Riverside. All right? So most of those places are cash only, right? So you have $6 to spend on apples and bananas. Here's your equation. 1.5x plus 0.6y equals 6. All right, you need to write that twice. Why would you write it twice? You got to solve for the x-intercept and the y-intercept. Okay? All right, so the equation, all right, and it says graph the equation, which we're actually not going to graph it. We are just going to solve for the x and y intercept and interpret them. I know, that's the part that's like, it kind of stretches your brain a little bit. All right, but remember, it has everything to do with the categories. Okay, so if we can understand the category, then we can understand what's happening here between the values. All right, how would I find the x-intercept of the first equation? How could I find the x-intercept? Does anybody remember? If I want to find the x-intercept, what do? Put 0 in for y. Go ahead and do that and solve for x. Go ahead and do that. Okay, when I plug in 0 for y, that cancels it out, right? 0.6 times 0, that would cancel it out, right? So now divide both sides by 1.5, and what do you get? X equals 4. So what is that as an ordered pair? 4, 0. 4, 0. Very good. Okay. Now let's come over here and solve for the y-intercept now. If I'm solving for the y-intercept, what do I plug in for x? 0. Okay, so that cancels. Now I divide both sides by 0.6. Did you do that? Did you guys do that? Okay, didn't do that one yet, but you're working on it. So what would y equal?
10.
Okay, y equals 10. So what does this mean? What does this mean? Well, let's write them as ordered pairs. That might help a little bit. Okay, what do these intercepts mean? What did x stand for again? X stood for what? Apples. What did y stand for? Bananas. So in the first equation, I had a 4 for my x and a 0 for my y. Could we put that into a sentence?
Yeah.
Someone raise your hand and tell me. Well, remember what x stands for and what y stands for. Gabe?
For apples, right?
Okay, I can buy...
Instead of 10 bananas.
Okay, I can buy 4 pounds of apples if I buy how many bananas?
0. Oh, 0.
0. I can buy 4 pounds of apples if I buy 0 bananas. Right? That's my x-intercept interpretation. Okay, anybody prefer apples over bananas? I'm an apples person. I don't like bananas. Unless bananas have peanut butter, I'm not all about it. What? And honey. Yes. Okay. Can you do the y-intercept now?
Okay, you're too much.
Can you do the y-intercept now? All right, go ahead and finish this statement. Okay. I can buy 4 pounds of apples if I buy 0 bananas, or what's my other option if I want it to be all or nothing? Can anybody raise your hand and tell me what my y-intercept interpretation would be? Gabe, you want to give it another shot?
Yes. I could buy 10 pounds bananas if I buy 0 apples.
Perfect. That's exactly what I wrote too. If I buy 0 apples. All right, now, Does it have to be all or nothing? Could I have bought a little bit of apples and a little bit of bananas? Yes, but not when it comes to the intercepts. When it comes to the intercepts, it's all or nothing. So that's why I took that approach here. All right, if you understand that, we are good to go for 13.5.